My name's Martina. I'm your moderator, but it's not about me, this session. It's more about it should maybe. Tomorrow, Women for Fire. Okay, that was my promo. But today is about Gino's talk, so yes. I'm happy to introduce you, and we will have some time for Q&A, and I'll get back to you with a mic, as you have seen before today.
Yeah, outstanding. Thank you. All right, hello and welcome. This is code generation for implementation guides. If that sounds too dry, you were probably in the wrong room. This is an experimental bleeding edge thing, and I'm pretty informal anyway, so please do, as much as it will bother, feel free to jump in. I'll repeat questions if they're quick questions, or we can find the mic. So very informal. Minutia-wise, it's on Whova. The deck should be on Whova. There's the link there, aka.ms/ginoc/dex. There's a folder for DevDays 24, and this deck is there with all the other ones. You can go back several years and see what I present on. It's a lot of fun. The quick agenda, I have the obligatory About Me slide, a disclaimer, some problem statement, context, generation stuff, and looking forward. So about me. I am a software engineer at Microsoft. I work in research in a group called Health Futures. It's a very fun team. We are completely outward facing, trying to improve digital healthcare globally. So we get to work on all kinds of fun stuff like this. I've been doing FIRE since 2019 here. Infrastructure, tooling, code gen, spec development, very low-level nerdy stuff. I was doing DICOM before. Much simpler interop story. Here's your CD. I think we nailed that one. And contact information for me as well. Zulip is definitely the easiest to get a response on. You can send it anywhere, but Zulip, you'll get a response. Disclaimers. This is work in progress. I feel terrible. I'd hoped to have it all done before I got here, and I'm oversubscribed. So this is experimental. However, this is also something that people have been asking for years, and so I've been trying to make it as top priority as I possibly can, and I'll show where we are, which I think I'm very happy with so far. So almost there. So what problem are we trying to attack here? And this is about making the use of implementation guides easier. We have a lot of talks. I even have another talk tomorrow about the authoring side and things that authors should be doing to make implementation guides easier. But, problem space is pretty big. Solution space should be pretty big. Let's attack it from the other side as well. And so this is all about things we can do on the technical side, tooling, different things like that, to say, yeah, we can improve our own lives, because that's what we are, developers. Write software for it. So all this stuff is based off of a code generator project I started several years ago at this point, and do maintain, but it is open source. The link is there, it's on GitHub. All the stuff I'm looking at is in the experimental branch. I was mentioning that earlier. As I started working on this a couple years ago for the IG part, I realized I needed to do a major refactoring of stuff, or I was going to be painting myself in a corner for several years, and did not want to do that. So this has an entire refactor of everything, so the project doesn't look very active because it's all in this one branch, and we have 4 work streams that are working on all the refactoring for it, which is almost done. So that's all in here. But that project is just building low-level code from the FIRE specs. If anyone's played with that kind of stuff before, reading everything from DSQ2 to R5, the type systems have changed, the locations of types have changed, how we represent them, the element definitions, all these different things have changed. So this reads them all in, normalizes all of it, and then you can output code. Really, you can output whatever you want. But we use this underneath in the Firely.net SDK for all of the POCOs, plain old C# objects. We use this as the base for the definitely typed, the FIRE definitions that are there. A bunch of open API stuff, which people only care about when there's a new regulatory requirement, and et cetera, et cetera. So for some context, IGs are packages. Completely not true, but useful here. So in reality, when we talk about an implementation guide, we're talking about a lot of narrative. We're talking about the definitional artifacts. We're talking about examples, all these different things. But as far as code generation is concerned, we really only care about the definitional or conformance artifacts. And so for us, we can ignore pretty much everything else and just use the package. They're mostly NPM. There's a few things that are slightly not NPM, but close enough. And there's dependency trees, which become important later, that you need to resolve as you go through all these things. So can we actually generate code? We're a few minutes in, and we should probably get to that. I've been doing, like I said, code generation for a while. I, at one point, tried to do all of the languages in parallel, like add a feature to all the languages and add a feature to all the languages. And I found that that was a horrible experience for myself and do not care to repeat it. So I started with C#, and I'm implementing everything there, so depth first, and then we can expand into other languages. I'm going to use this concept of levels in this, and I've used it in my OKRs and everything else, just for my own sanity, as far as tracking progress. And, shameless plug again, this is all open source, so please review, contribute, whatever you'd like. All right, so getting down into it. Level 1, extension URLs. Anyone who's ever read an IG, I'm sure all of us have had the same experience, or I assume, at least my experience, has been, you're looking at a profile and then you see that there's an extension and you need to click through the extension to get the canonical URL because you need that in your code. And then you put it in the file first and then eventually you add 2 or 3 and you're like, hey, I need this from some other module, so now I'm gonna refactor all that and put them in one place, and what happens when I need it from a different IG, or it's a mess. So we said, okay, the most basic thing we can do is grab the canonical URLs, build some useful comments, and output that. So we have that. All right, we grab all the definition, comments, purpose, all these different things that are different in all the different versions of the Fire. We can see that this is the allergy intolerance abatement URL, or extension. And we generate a file in a packet, in a folder for this URL. The summary has the definition, and in the remarks, I put the allowed contexts and allowed types in the URL. So you can see in this case that extension allows for date, times, ages, periods, ranges, and strings, and you can just get that information nicely in line in your editor. Okay, but what if we get a more complex URL or extension? Yeah, we can do the same thing. So same thing here, we have the artifact assessment content extension, and we can see that we have the same description, it's only allowed on basic, and we have a bunch of sub-extensions that are allowed. And so this lets you start following through and nesting when you have extensions, because that's something else that always annoyed me, is you say this extension has 5, 6, 10, 15, I think there's one particular IG that someone in this room has authored that I think has 40 or 50 sub-extensions. And so that gets pretty annoying to track. And so in this case, you can go through and find all of those directly. So I'm like, all right, declare victory, we're done, and that's it. No, not really. I'm a developer, I'm never happy. So move on to level 2, value sets. This is where we start getting a little trickier. Like just grabbing canonical URLs and definitions is pretty straightforward. Once we start thinking about some of these other things, they get increasingly complex. So when we're doing value sets, we do need to resolve the dependency tree and/or use a terminology server. We need to expand so that we actually have the codes. We need to filter for the impossible sets, UCOM, SNOMED, things like that, that are post-coordinated or have language definitions. There are no expansions, so generating one would be time-consuming in that it will run forever. But we can generate documentation, and we can create some classes. Played with a few different things, enums versus classes versus different things. In the end, Ewout and I settled on codings in C#, because the coding, you can down convert to a code, or you can up convert to a codable concept. And then we started saying, you probably want some utility functions too. So for instance, you want to say, I have this codable concept. What codings do I have out of this value set? Okay, that sounds useful. So let's generate them. Same thing, and I use this one for a particular example, the allergy intolerant substance exposure risk. This is just a random one picked out of one of the packages I started with. And you can see one of the downfalls of code generation, description needed here. We can only use what's in the artifact. So in this case, the artifact definition says description needed here, and I have 0 chance of actually filtering for that. I'm not going to go and find all the types people do that. We find some. A lot of times people will put a short, and the definition is just the short plus a period. So we do find some of those things, but arbitrary text like that, we're not filtering. But in this case, we can see we have a static class, and then we have these codings that generate a new coding with the right system, right code, and right description. So you can grab that coding and down convert it to a code if you need, or use them in a list and make a codable concept. Same thing I was saying, there's the, right now I don't love the name, but filter for this set. So essentially saying, here is some enumeration of codings, might be from a codable concept, might be just a list of codings, and you're asking which ones are from this value set. And so we just generate the code coming through and saying, hey, go through all the things I passed in, check to see if the systems and code match, and return the ones that are. We do play a lot with looking at the IL and disassembly, and this type of thing gets very nicely optimized by the compiler and the JIT. So some of these things look inefficient, but that's because the compiler does it, and then I shouldn't expand and unroll loops and all kinds of stuff because it'll do it for me. All right, so then we have value sets. We're done. We can do better. Let's do some extensions. So again, we get a little more complicated. We need to read the structure definitions. We need to pull out all the comments and everything. We need to resolve the dependency tree because you can have extensions with things from dependent packages. And then we get the really fun stuff, which is consolidating contexts and types. And in this case now we're generating getters and setters, and everything's nullable, so you can remove them inline without putting an extra clear function. So what do I mean about consolidating contexts? This is where we start getting into the output language, and we need to understand how the modeling has occurred in that language. So we have a path like questionnaire.item, and we need to take that and figure out what the type is in our target language. And so there's a lot of fun edge cases in the spec because the spec is full of them. So things like bundle.link is a named reference, so then you get to something else that has to use that same type even though it's not the right path. You have to know the reserved keywords in your target language, all this kind of stuff that we've played with for code generation, which makes it so complicated. Once you have all that, then you have to go and say, how do I resolve these so that the compiler can be happy with the code I output? So for instance, if you have an extension defined on resource and patient as the contexts, I can't put those in the compiler because patient inherits from resource. And so I have to go through and figure out, okay, in this case, patient is a subclass of resource, so I only output a definition for resource. Same thing for things like elements versus patient.active and things like that. Once someone adds element as a context, you don't output anything else and all that stuff. So that's pretty fun. Then you have to do the same thing with types. You have to understand first the things about how you actually compare these types, that you say fire has an integer type. It might be int, it might be integer, it might be number, depends on the target language. And then you also have to reconcile how you do choice types. Firely, the C# and the happy were developed at the same time. So they both chose data type as the type name, which is fun. But like in TypeScript, we have interface unions. We don't have a choice type, it's just a union of interfaces. And so you have to understand all of that in order to output, again, something that the compiler will be happy with. But we can, because we have all this stuff. Well, we write all of it. So same type of thing. We have an extension. We grab some comments. We have remarks. We have the same type of thing, the allowed contexts. So this is the abatement extension that we were looking at before. And we have a getter and a setter. I'll come back to that later. We have the allowed contexts and the allowed types, which I leave in here because if nothing else, it's a good sanity check for me. And then this is a C# extension function that's on the allergy intolerance resource, so that when you just have an allergy intolerance, you just dot, and we'll get to that in the fun parts later. And then it reuses these definitions that we output for the extension URLs and things like that. because I don't want to litter your executable with strings that we're defining 100 times. So you can see there's a getter and a setter, and it knows to remove the extension if you pass in a null and all that kind of stuff. Yeah. But what about complex extensions, right? Like, that was a simple case. Well, complex extensions are really just nested extensions. So we went through several iterations of this. We talked about tuples. We talked about expanding out the definitions themselves. We ended up with landing on record classes. Brian Postlethwaite actually was the one who had the winning decision there. We were all voting for which ones we thought would work the best. And then same thing, we want to be nullable and all this kind of stuff. So these are getting a little small, and I can zoom in again here in a minute. But we create a record. So in this case, we have the allergy intolerance substance exposure risk record. So we create the class. This has two properties in it, a codable concept for the substance and a codable concept for the exposure risk. So that way, the magic happens when we say we have a getter and a setter, and it can return that record. And inside this function, we go through, get the extension. If we don't have the extension, we return null. If we do have the extension, then look to see if there's the right sub-extensions for these parts, fill out the record, and send it back. All right, I'm pretty happy with that. Declare victory again. Oh, wait, I forgot the setter. See, I got ahead of myself. Can't declare victory. The setter's a little more complicated, a little more code, but the same thing essentially, just checking through the nests to see what's null so that you can say, I remove this one sub-extension from here or not, all that kind of stuff. There you go. Then we declared victory. But what about profiles? Profiles are pretty annoying to work with. Well, let's see what we can do. We can grab some documentation. We can grab things like must supports. We can get some canonical information. We could probably do some accessors. So same type of thing. We have a summary based on, this is from SDC. We have a list of must support elements defined in SDC base questionnaire. And that way when you do the code completion, mouse over, all that kind of stuff, you can see all of the must support elements that are in the profile so that hopefully you don't have to keep going back and forth to the IG as often. What's in there? Well, we have the URL, we have the version. Thought that was pretty important kind of stuff to have. And I warned you, this is work in progress. So eventually we fall off the cliff. And this is literally what I was working on that I was trying to have done before I got here. So you can see the comments are more debug output than actual comments. And this is going through the very annoying process of reconciling slices and sub-slices and all these other things. So in this case, this is the SDC base questionnaire assemble expectation slice. It's on a questionnaire. And we can see it's an extension for assemble expectation. So we want to reuse that same extension getter that we had before, keep layering these things up so we don't generate extra code we don't have to. And then we have even more fun ones that are slices that have extensions that have sliced extensions. Same thing, we can generate a class for that. So we create a record class for behave item max occurs. The base of that is an integer, and then it has two sub-extensions that you can have the max occurred calculated and the max occurs expression. And one of those is a string and one of those is an expression. So same thing, we can take all of that code we were figuring out before, so we're reconciling types and context and all that stuff, and just keep reapplying it as we keep walking down the stack. It does get same type of thing. You know, again, this is the debug comments instead of real comments. But you can see then we have a nice getter that returns a record of that type and goes through and walks the tree so that you don't have to. So the payoffs, this is the fun part. So I have some screenshots here, and then I have it open in code as well in a second. But you can see, hey, I have my patient. And because I'm in C#, I just did patient dot, and I started typing US core. And in this case, it has all of the extension getters and setters from the US core patient, because I have that in my using statements in my C# file, and it can just present them to me. Same thing, here I'm showing it with a little more, doing the same thing with the questionnaire. So I have the base questionnaire and the questionnaire behave. And you can see as I start typing SDC, it starts filling out all of those for me. So, for example, this is horrifying code right now, just because this is the version that was on my laptop, and I was going to start making changes to fix things and said, that's a terrible idea, don't do it. And I am very proud of my restraint. So you can see when we're exporting these things, we go through the packages and we start exporting folders for US Core 610 and NLM VSAC 11 and SDC 3 and backport 110. So we get all these folders, and all those folders have the definitions, extension utilities, all the different value sets. Some of them get pretty big, like VSAC, I think. Yeah, VSAC has lots of value sets, lots and lots of value sets. And all this stuff, the idea is we'll generate the code, and then if you're not using it, it doesn't get included when you actually do your build, and so it's not inflating your code as much as it could be. So we are aware of those types of things. But you can see in my program, I have things like extension pack, and I'm using the CI build version of the extensions pack, and then I have my extension URL. Outstanding. I can just do a nice dot path to get to it. I can see the URL there. I can see the allowed contexts. All those things are in my comments. I can F12 to get to the definition. They're all grouped together. So brand logo, license type, license, and bundle are sub-extensions, and their definitions are right here as well. Lots of red. Again, that's what I was going to start fixing. All right, but what about patient? Well, same thing. We're just typing here, and if we start with patient dot, we just start typing US Core, and here are all the extensions that are available directly on US Core, or on the patient object. Because we're defining the extension classes, they all show up exactly where they're supposed to, and that's it. So in this case, we're creating, for instance, a US Core race extension record, and that's a complex extension that has a race category, a text, different things like that, and we can just set those properties here, all nicely, OMB category. I believe there's another one here. Detailed, yes. So we can do the detailed, and then same thing, we can just keep passing through all these different things. All right. Questionnaire, same thing. You start saying we have the questionnaire profile here that we added as a using static. We do have to be careful about how we scope things. If you just start saying all the profiles from US Core and all the profiles of SDC are all in scope at once, your autocomplete box gets very long. I don't have any magic around that yet, except for scoping them here. So we try to structure things so that you can. But you can see questionnaire has some things on it, but we can also do questionnaire.item. And then we have the ones that are on questionnaire item. So same thing, we have all these things nicely scoped to where you're allowed to use them, which should simplify life. At least it simplifies mine as I play with them. And then just, yeah, this is another one. Answer expression is on a specific item, so then you can go through there. So, looking ahead. First is the minutia part. We have to finish up some work. As I said, we were refactoring the whole core of the code generator, which is very frustrating because we have to make sure we don't introduce any breaking changes into any of the languages we generate. So we have to go and match, even though if we improve a behavior, we have to go and put in patches for the old behavior until everyone downstream can use them. So we have things that we detect better on value set expansions or different things like that. And it's like, oh, that would be a breaking change. So put in a patch to bypass that until the next major release of that SDK. And we have to do that with all of the languages at once. Same thing, there's obviously things to clean up in here. So we'll get through that. And then this is also what I'm using for generating cross-version extensions, which is a whole nother topic, but that's all in here as well. So lots of work streams concurrently in this project. Distributing this work, I know that that's a question that comes up. This is right now obviously on GitHub. We've looked into a source generator. I think Christian's in here, yeah, there he is. He's done a source generator for the core stuff before for custom resources and things like that, which worked very well. Unfortunately, when you start getting all these IG packages with their dependency tree, we need them all in memory. And so what I found was something like US Core takes about 3 gigs of RAM. And that's because we have VSAC and all these other wonderful things in memory. We can't generate code without it. So I would love to say we have some sort of weird optimization we can do, but quite frankly, for a source code generator, I don't personally think it's worth it. Open source, if you think it is, please feel free to submit that PR. So anyway, we're leaning towards a .NET tool. I have some extra hoops to jump through because this is in a Microsoft-owned repo, so I have to do all this code signing and all that kind of stuff because it's in the Microsoft namespace. I am doing all of that, so it will be available as a .NET tool after we merge it in. Maybe a website, we'll see. Something where you can just select a package and get your code downloaded, so if you don't want to run it yourself, you know, again, it's a pretty expensive thing to be running just because it loads all these packages into memory. So I'd prefer not to pay for that bill, but we'll see. We have talked about NuGet packages. So like you could just download the NuGet package for US Core 6.1. We haven't decided yet. In part, it's very challenging because you have the version package of the version of the package and the version of our source code. And so then we have to do things like saying, here is the US Core 3 version 1.0 and the US Core 6 version 1.0. And then if we want to move our stuff to 1.1, we have to go back and regenerate every single package we've ever done so that we have US Core 3 1.1 and US Core 6 1.1. And that's a lot of packaging and building and just compute time. So if it turns out that we all agree and that's really nice, we'll figure out a way to make it work. But let's walk, levels. Let's walk first. So looking ahead, like I said, FireLeaNet SDK, we're going to finish the profile support. If there are other things that people think would be useful, let us know. I'm happy to do level 5, level 6, level 7. I love doing this stuff. It's a lot of fun. Particularly things around canonical resources. I'm already trying to figure out if there's useful things to put with subscription topics or other things like that that we can put kind of helper functions in for. We'll see. Might just be URLs and versions. That's a pretty good starting point for most canonical resources, so we'll go from there. Super excited. I haven't actually been able to catch up on build because that happened during the workgroup meeting, and I've been swamped since. But C# 13, for anyone who's doing C# development, we can have extension properties in C#, which means I don't have the Java styles getters and setters. I'll just have properties, which is a much better output. It does mean I have to refactor a few things here, but that's okay. That's what keeps me employed. Other languages. So that's what I was talking about before. I started with C# because I prefer that toolchain. The level 1 stuff is trivial, so I can see getting that added to TypeScript and whatever else pretty straightforward. Level 2, pretty simple, finding the coding type and getting an example of that. So we can start adding that for some languages. Once we get to level 3, we need someone who understands all the models and types and contexts and everything else in that language. So for something like the happy classes, I don't. I do not have that level of expertise, and I am not going to get it anytime soon. So for things like that, if your language du jour is not one of the ones that I can do it for, please feel free to contribute or discuss or provide examples, and I can very easily take examples and make everything match them. You'll have to tell me if they're correct or not afterwards, but that's the fun of all this stuff. And so with that, oh, look at that. I'm running on time.
I didn't have
sorry,
a chance, Gino, to do
before.
the 10-minute sign because we still have 15 minutes.
Oh, we still have 15 minutes. I can keep showing stuff for another half hour. No. So I did actually want to save some time for questions, discussions, requests, comments, whatever people would like. And I can see some already. Yes. Oh, sorry. Yeah. Yeah.
In reference to the previous session about the snapshots.
Yes.
Are you using the snapshots or the differential?
Okay, so for people that weren't in the Fire schema session, that's what we're referring to, is we had a philosophical debate about snapshot versus differential. For code generation, I very much prefer snapshots. I can process differentials, and I actually cheat now because that was part of the refactoring. Is I'm using the code from Firely, which is built on the code that I'm using. It's a lot of fun. But in there, they have their snapshot generator. So I have cheated because I wrote all the code to process differentials, and especially when we get into these types of things, the profile slices, there are lots of gaps in the differential, and particularly around extensions, because extensions got all this implicit behavior, which if we had a time machine, well, if I had a time machine, I'd do something else. But if we had a time machine and could go back and change that, I would very much ask that a lot of these implicit rules be made explicit, because we have to guess. And so when you're trying to traverse a differential and you're finding paths that jump 3-4 levels nested deep, it can be very hard to reconcile that. And so I had a couple thousand lines of code doing that kind of stuff. And then I was working with Ewout, and he's like, well, why don't you just use the snapshot generator? And I'm like, well, because it's not documented, and I didn't know I had access to it here. And then he's like, no, yeah, sorry. Here, it's this line of, 2-liner code. And now when I'm loading packages, I go and check to see for things that don't have snapshots and run them through the snapshot generator. And that simplifies my life downstream. So, well, I'm out of memory either way, because the real problem is that I have to, oh, sorry, he was saying I'm out of memory for the recording. The problem is the actual structure definitions are pretty small, so that's not a problem. The problem is really the value sets, and because I'm reconciling all these contexts and trying to reuse the definitions, I don't have a good way to unload them. I could figure one out, but it comes back to the same thing of how many tens/hundreds of hours will I spend optimizing that for something that is, you're going to run this once, and then maybe run it again 6-9 months later, like, if there's a new version published. For me, that's the investment, the opportunity cost that I could do other things. And it's the same thing here. The thing we were refactoring, I had written all this stuff from scratch before, all the models we parse into and all this stuff that did all the normalization into these custom objects. And it was blazing fast and super efficient and everything else. And I said, well, I should use the Firely stuff. And when the first time I had the full build working, I went from generating one of the core specs in 3.4 seconds average to 6.8 seconds. And my first reaction was, oh my gosh, I have to fix this. And I started diving into all this stuff because we've done a lot of work on serialization performance and things. I'm like, oh, where can I squeak some time? And then after a couple of days, I'm like, it's 3 seconds in a build pipeline that no one cares about. This does not matter. And so we do have to try and keep ourselves grounded on those things. And so for some of these things, there would be other ways to do it. And if we get to the point where we say that's worthwhile, again, if someone else wants to get to the point where they think it's worthwhile. But I'm open to it. It's just that I can't justify the development expenditure to do it yet. So. We're still in questions. Yes.
Just to share.
Yes.
We are. I work for Singapore Healthcare, so
Yes.
we're using a lot of custom resources.
Yes.
And since we use .NET, we initially what we did was we handcrafted the resource class.
Yeah.
And that led to a lot of mistakes, like when we update the new version of Firely SDK, it seems like you need to implement a new method.
Yeah, there's a lot of,
so,
as we implement more things in the Firely SDK, we add new decorators or, a new function that's part of the default model, and there's all kinds of stuff like that that comes across.
Get name values was one.
Yes.
So that's why we went into the journey of using your source generation. So we found that it was very difficult for us to use. So I created the source generator. So we just create a partial class and decorate it with the location of the structure definition, and it will generate the resource class for you. So what we found was one of the pain points was that it required snapshot. So
it doesn't anymore.
It doesn't anymore. So I'm glad to hear that. And also since you probably are not like actively developing that. So I would appreciate if the source generation code targets net standard 2.0.
Yes, yes.
Because you should ask your colleagues in Microsoft to lift that restriction in Roslyn.
Oh, I will file a bug report. How's that?
That's cool. So yes.
Yes.
Yeah.
And yes, and this is the kind of thing, and that's the hard thing when you're building developer tooling. For your use case, 100% agree the source generator is the way to go. It is lightweight enough because you're not loading, thousands upon thousands of value sets in this giant dependency tree with, and we can go through and look what it does, but I think US Core actually even includes the examples package from the core spec, and I don't know what it's going to do with it, so I have to load it. And so all these things get very complicated, which there's other things to fix. But yes, I want to be able to use the source generator, and that's why it's hard to delineate where we say which part does and doesn't make sense. And so, yeah, definitely, even if I don't build one, I guess that's the beauty of open source, you can and have. And so I definitely want to make sure that that does continue to be supported, and yes, I will make sure that we have a story for you.
Okay, glad to hear that.
Yes.
Thanks.
On the experimental branch,
Yes.
I just wanted to understand to what extent other languages still have support. So on the main branch today, you're doing TypeScript generation,
Yep.
et cetera. Is that still true on experimental?
Yep, that's one of the reasons why it takes so long is I have to make sure there are no breaking changes in any of the supported languages, and I hold myself to that standard. So I'm going through and testing C# with Firely stuff, TypeScript, OpenAPI, and OpenAPI alone is so annoying because there are hundreds of configuration options about single file and multi-file and what level of schemas are you including and all this different stuff. And I'm testing all of it to make sure it's all non-breaking.
And follow-up question, do you have type generation for profiles working for TypeScript?
Not yet.
Okay.
C# first.
2 years later.
Yep, C# first. Well, part of
Because
what
Nikolai showed me he's got.
I'm sorry?
Nikolai showed me he has profiles
Yes.
generating with Fire Schema, so I thought
Yes.
that was interesting.
Yeah, and the Fire schema, and that's why that's a whole interesting discussion. Again, if you haven't seen it, it was recorded, so I would recommend catching up on it. It's interesting to see where the limits on these things go. One of the good examples I can say is like when Graham was talking about the Fire OMOP stuff a couple of workgroup meetings ago, and people were saying, yeah, OMOP's so great because it's such a simpler model. And it's like, well, yeah, that is great if the simpler model meets your use case. But it doesn't. That's why Fire is complex, is because we have to account for all these use cases. And so when we start saying things like Fire schema, for the specific thing he's working on about validation and, so far non-terminology validation and some of those things, it is fantastic. It's much more performance, and I 100% want to push on that type of thing so we can do inline validation more and things like that, which, as someone who came from the DICOM side, I was appalled that we weren't all doing that already when I switched to Fire. And so there's things like that, and we just have to make sure that it meets the cases we need, and if it doesn't, then we write something else or figure out a way around it. So, yeah, for sure. It's a good project, though, and they're very smart people. So if you can use their stuff, I can deprecate mine.
I wanted to go back to a comment you made around, running this every 6 to 9 months.
Yeah.
And I wanted to understand whether or not that was like kind of a natural expression of that's how frequently we're seeing releases come out in the HL7 space, or technical complexity of having to run this around every major or minor release. As an author that's looking out producing more frequent minor releases, I'm trying to understand if that's going to create challenges here.
For me, and I could run it here off my laptop, and that's why something like generating the US core ones, because it's loading tons of packages and stuff. Obviously, if you have to download it, you have the internet transfer time and things like that. It takes 10, 15 seconds, but it uses, like I said, 3-4 gigs of RAM because it doesn't know what it's going to need. So it has to load everything from all of the packages and then figure out what it needs from there. And I could be smarter about that, like I said. The 6-9 month thing was just for me being in reference to saying, assuming this is done, because it's obviously not done right now, but once I have the working version of SDC 3.0, what do I need to regenerate it for? Like once I've output this code and have it in my project, this is what I'm going to be using. Maybe there's a new version of SDC. Maybe we've improved the code generator and you want to grab some new feature from there that we're generating. I was just throwing out a number, picked from a hat, based on my experiences of saying how often do I go back and revisit my hand-maintained code in IGs and things. And it's like, well, someone filed a bug report because I made an assumption that was wrong. Like, oh, okay, yeah. I might go and regenerate and things like that.
Hi, I'm just wondering how easy it is to extend the code generator for generating arbitrary config files or whatever I might have in my project that is necessary.
I've tried to make it very easy. You would probably be able to give me better feedback than I can provide. And this is going to be terrifying to try and do inline because this is not the normal thing I use for this. Oops. Let's see. We can go to here, and I'll just open it in VS Code, even though that's not what I would use to edit this normally. We can do one of these, and we can zoom in a bit so you can see what I'm talking about. So, again, part of this project has been running for probably 4-ish years now that I've been running it. And since I had to do a major refactor, I tried to take into account all of those nice things that I would have liked to have done the first time. And so, we do have, common files here that have, same thing. Since we don't have code generation yet, this is one of those files I was talking about. I have my sets of extensions that I need to use during code generation to read things like the standard status and FMM level and best practices versus capability statement expectations, and I have to come up with names and all that stuff. So I have things like that. And then I have a whole ton of, where are these? That's the great question. Where did I put all these things? Models. Is this the right version of any of this? This is obviously not the prepared part of this talk. Oh, there we go, Fire extensions. So I refactored it all to use Firely, and it's using Firely R5. So that's one of the fun things I had to do during this refactor is I'm reading like DSTU2, R3, or STU3, R4, R5, all those different things. And then I manually wrote all these converters that take iSource nodes and map them and all that kind of stuff. It's a lot of fun. But then you can just use the Firely definition, structure definition, element definition, and use all the Fire properties. That's not great, and so then I have all these extension functions to just get like the simple name or get the regex value, or if this is a simple type, and all these different things that you want to collapse into these nice utility functions. So when you get down to the actual languages, we have this nice set of language files, and it's really dependent on how complicated your model is going to be. So like for OpenAPI, this one is the thing that actually builds all the OpenAPI stuff, is about 4,000 lines long, but OpenAPI is super complicated. I have one that's like the info language that just kind of outputs a bunch of stuff, and that one is 1,000 lines, and probably 300 of that is boilerplate. So something like this that goes and just outputs, for the specs, it outputs things like this. That you can see here's the contents of the entire package, all the primitive types with all their info, the complex types, resources, all that kind of stuff. And so that's, a few hundred lines of code. So it shouldn't be terrible, and I'm happy to help if you're working on stuff like that. I always enjoy. And then it sets me back to the beginning. I can listen while I hit down.
Sorry, quick question. How much of this work is reusable if you want to support another language, let's say Python, Golang?
Yes, so that's where I was talking about these levels. Like the level 1 supports to do something in Python or Java or something like that, almost 100%, because that's navigating the structure. All the loading code stays exactly the same. All the parsing code, processing code, that all stays the same. And then we're just looking at, the single function that does the actual generation, which I have in this folder, yeah, like the net IG. And so I realize that this is going to be a pain in the neck to find here. But yeah, almost all that code could be reused to generate something in Python like that. When you talk about the level 3+ stuff, there, I don't know. Since I don't build Python models today, I don't have any sort of concept of how hard it is to take an arbitrary element path and get the type out of it. So whatever the underlying type model is, we just need to put in functions for that. You know, all of the actual recursion and all those different things, that's all reusable. But yeah, I don't know what the choice types are, how they're handled. I don't know how you actually do extension method equivalent in Python and all that kind of stuff. So someone who knows the FHIR model in Python and is expert in Python can provide that information pretty quickly. And I'm happy to go back and forth and iterate on that.
If there's a last very urgent question, we can do it, and otherwise it's time to go to the break.
Yes. Can't step on cookie break.
Oh, is it cookie break? Yeah.
I don't know. I assume. The cookies yesterday were delicious.
Managing
For everyone watching,
expectations.
sorry.
Thank you all, and thank you, Gino.
All right. Thank you very much.